All right, good morning, everybody. So welcome to CMPE 212, Introduction to Computer Science number 2. These slides are the first deck of slides are kind of useless. Everything is on cue, so I'm just going to go straight on to on cue. Okay, so I am Dr. Burton Ma. That's my email address right there. Office hours will be posted later this week sometime. There are 2 teaching assistants. I will fill in their names and contact information later this week as well. If you need to get a hold of me, the best way is through email. Don't send a message through Teams or something like that. I'm not going to see it. If you email me, please put CMPE 212 somewhere in the message so I know who it's from, because I teach 3 courses. If I just get some random email from somebody saying I need blah, 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 I'm not going to know who you are. Okay, so lectures, well, you guys, you know when your lectures are. There's also labs in this course. So the labs are mandatory. They start this week. And I'll explain a little bit about those in just a second. You're supposed to come to the lab section that you are enrolled in. So starting tomorrow at 2:30, a small number of you have a lab, right? And then there's Wednesday and Friday. The Friday lab section is unfortunate, but that's what we're stuck with. I have no control over the scheduling of these things, right? It's the university that schedules everything. There has been a request for note-taking. So if anybody in the room actually takes notes, there is someone in the class, at least one person in the class, who is requesting they have access to your notes. So if you're willing to do so, click on that link and find out more about this request for note sharing. All right, so what's going on here? So if you go under Content, and you go to the course description and requirements, you can find out about the course. There's the standard calendar description, which I'll get to in just a second. Textbook. So there's no textbook for this course. If you want a reference for the course, there's any standard Java textbook will do. Right, so the course is taught in Java. Again, not my decision, but that's the language we're stuck with. So you're going to be, so any standard Java textbook will do. Most of the standard Java textbooks are stupidly expensive, like $200 or $300. Don't buy them. It doesn't make sense. The library does have one that's electronic. Well, the library has several that are freely available. That one is particularly good. So if you click on that link there, that will take you to the library link for that book if you want a textbook. There's another book here, which I'm going to reference often in the course. It's written by one of the guys who actually wrote the language, Joshua Block. So if you actually end up in a professional programming job where you're working in Java, that book is probably something you need to read at some point in time. Grading scheme. So labs are mandatory, so there's 12 of them. The first one's not marked. So the first one, basically, I'm going to show you how to use the course software to make sure that you're able to actually do the labs in the subsequent weeks. Right, so there's 8 assessed labs, worth 5% each. The idea is you do your work in the lab and you're done. You don't have any more work to do for the week. Right? So there's no homework in this course. Well, there's not supposed to be any homework in this course. Right, you have 3 quizzes during the term. The dates are shown there. Right? So those dates, I'm pretty sure, are firm. So you can write those down and commit to those now. They're worth 15% each. They're done in the lab. Right? So you show up for your lab. It's a written test. You do your test. You go home. Right? And then there's an exam. The exam is not comprehensive. It's effectively another test. So it's basically testing the stuff that I didn't test you on during the course. Right? So not a comprehensive exam. Right? Typically, these things are like 90 minutes or 2 hours or something like that. Right? Because your lab's only 2 hours long. So your exam is also 90 minutes or 2 hours. I forget how long I said it. It's something like that. Right? So again, the idea is that all your coursework is done during the labs. Except for extra studying, you shouldn't have to do any homework or anything like that. Right? So there's no additional time commitments other than what's in the labs. What else is there? Textbook. Oh, lectures. Lectures. So if you go to the lecture section, you will find all the lecture slides for the course. Right? So they're all here. If I update them, there'll be a little note inside or beside them that's saying they've been updated. Right? So whenever I find mistakes or something, I'm going to correct them. Well, I might correct them and then I'll post the correction here. The lectures are all recorded. So if you click on that YouTube playlist will be updated during the year. So after every lecture, sometime after every lecture, I will post a recording of the lecture. Right? I'm not always very quick about posting the lecture. So sometimes they may not show up for a week or so, but they will show up there. There's a link up here. So this course is basically the same as CISC 124, which is the second or third computing science course for computing science majors. It's more or less the same. It's also Java. Historically, it was always the same. That's changed as I've taught this course more and more and more to swing the course material more towards engineering rather than computing science. If you click that link there, that will take you to a set of online notes that are very comprehensive. So this is effectively another textbook if you want it. I'll click on it and we'll see how it works. Hopefully it works. There's a whole bunch of software involved in making this thing work. So if you click on that link, you're going to get to this page here called Binder. It's going to try to load something. It usually works. Right now, this is running on someone's server somewhere in the world. They've donated time for free for this service. And when this loads, you'll see that there's a large set of online notes. So we'll come back. Oh, it's coming now. I used to make this available to students directly so they can install it on the computers, but there's a lot of software you have to install. And if you have a Mac, it doesn't work. So now it's just online. But you see here, everything that's in the course is covered in these set of notes. Right? All of these notebooks, also all of these individual notebooks, they have exercises embedded in them. So let me just quickly jump to one of them, for example. So I'm just going to click on this for no particular reason. Has anybody here used Jupyter? Anybody? Okay, so this is Jupyter. This is just straight Jupyter. Right? But it's Jupyter able to run Java, which is the problem, because Jupyter wasn't really meant to run Java, which is why there's so much extra software that you have to install. But this is basically Jupyter. So if you've used a Jupyter notebook before, this thing is a textbook for Java written in Jupyter. Eventually, I will get to something interesting. Where is that? I'm looking for a code cell somewhere. Here we go. Right? So eventually, you'll get to a code cell. Right? You can run these code cells in the notebook. Right? So I can run that. That's going to print something any second now. It's slow the first time you do something. There we go. Right? And so you have this output here. You can edit this directly in the notebook. Right? Now, when you edit it, the edit's not permanent because this is running on someone else's server. Right? So if you changed something here, so blah, 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 and run it again, right? The cell updates, recompiles, runs, and away you go. So you actually have a set of online interactive notebooks if you want them. Right? The notebooks are far more comprehensive than the lecture slides. So if you are reading the notebooks, you're going to learn a lot more than you will just by coming to the lectures. But I'm not going to test you on stuff that's in the notebooks. Right? Only the stuff that's in the lectures is what's relevant to the course. Sorry, is what's relevant for being tested on. Right? There's a lot of extra content in the notebooks. There's exercises in all the notebooks. Right? And if you go back to that starting page, at the end of every main section, you will find solutions for all the exercises. So if you click on that, as far as I know, every exercise has a corresponding solution. Most of them are written in code cells, so you can edit the solution too to see what happens if you change them. Right? So you are free to use these notebooks if you want. You're not required to do so. Right? If you want extra exercises for practice, I'd encourage you to look at the notebooks. Right? It's the only place you're going to find answers. Right? Most textbooks don't provide you with the answers, although I'm sure you can find them. Lectures are all here, labs. Software. So this is a Java programming course, which means you need to get a Java development environment installed on your computers. And so if you go to course reading and resources, right, you will find links for installing all the software you need if you're on a Mac, if you're on Windows. If any of you are using Linux, you can figure it out on your own because you're using Linux, right? I'm assuming because you're using Linux, you'll be able to do it on your own. But if you're using Mac or Windows, excuse me, just click on those links. Basically, you need to install what's called the Java Development Kit, and you need to install Eclipse, which is the editor that we're using in this course. Right? Where is Eclipse anyway? It's here somewhere. Here it is. So I'm just going to start it up now, and then come back to it in a minute. You're going to find it's quite slow starting up, especially the first time. All right, so if you're coming to the lab tomorrow, you need to make sure that you get the stuff installed on your computer for tomorrow, right? Thursday or Friday, you need to make sure it's installed for Thursday or Friday. All right, any questions about, oh, what happened here? Okay, do we have any questions about the course administration? Anybody? Anybody? All right. Okay, I guess we'll start here. So what have you gotten yourselves into? Well, you've gotten yourselves into an introduction to what's called object-oriented programming. If you've only taken Elect 278, I guess, and your first year applied science course, you would have done just straight C, which is not object-oriented programming, right? That's, people will call that a procedural programming language. So in an object-oriented programming language, the structure of your program is different. The way you think about your program is different, right? But that's really the only difference, right? It still resembles C. Java in particular is very close to C, right? There's a bunch of other stuff here. We'll get to all this other stuff as we go through the course, right? But that's what you're here for, right? You're learning about object-oriented programming in Java, right? So object-oriented programming, it's one of the most widely used forms, one of the most widely used programming paradigms right now. For engineering, if any of you actually end up programming in an object-oriented programming language, you're probably going to be doing it in C++, possibly Python, but probably C++, right? So I would argue that's actually a better language for teaching this course. Powers that be have chosen Java, so we're stuck with Java. All right, so structured programming or procedural programming, that's what you learn in AppSci 142 and Elect 278, right? You've got loops, you've got if statements, you've got functions, and that's more or less all that you have, right? In object-oriented programming, your program is made up of these things called objects, which is why it's called object-oriented programming, right? Your objects, they contain the information that your program is using, right? So they have what's called state, right? And all of your objects, they also have methods, which are basically just functions, right? But the methods, they operate on the information, on the data that the objects have, right? And so you have, typically in an object-oriented program, you have many of these objects that interact, right? So objects ask one another to do things, right? So they interact with one another, and in the object-oriented jargon, we say that they pass messages to one another. All that means is that they call methods belonging to other objects, right? If you were to continue learning more about computing science, you will very quickly discover that there's many, 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 many other ways of writing programs, right? Not just structured programming, not just object-oriented programming. There's a whole bunch of other ways to write a computer program, right? But that's not relevant for our purposes. Okay, so what's Java? So Java is a programming language, right? It's general purpose, so it's not really intended for any one thing. It can be used for many different things, right? Cross-platform, so that means it runs on many different types of computers, right? It'll run on your cell phone, it'll run on your desktop computer, it'll run in the computer in that projector, for example, and things like that. And it's object-oriented. Right? So it was created in the early 1990s, 1991, I think. Right? And it was created to address issues with the dominant programming languages at the time, one of which was C. Right? And so Java was a reaction to the C programming language. Right? As you all know, it's not particularly easy to program well in C. Right? In particular, because the programmer has to manage memory. Right? So Java tries to remove that burden from the programmer. Right? It's got a bunch of goals that when it was designed, it's not really important right now. Right? Okay, so where is it used? So it's not really used tremendously in engineering, which is why I don't know why it was picked for this course. But here we are. Where it's really used in this is in this thing called enterprise software. So this is the software that huge organizations use, like banks or the university. Right? Any large organization that deals with lots of people, that has many different systems that have to interact, a lot of that software is all written in Java. Right? Server side, so any computer that sits on the internet that services requests that come over the internet, often the software running on those computers, written in Java. Right? If you heard about big data, so big data is basically, so the large companies have collected lots and lots of data on lots of different things, whether it's on you or things in the world. Right? They need some way to organize and access that data. The way that data is organized and accessed, a lot of that software is written in Java. Embedded devices are devices that are computers that don't look like computers. So that projector, for example, or your Wi-Fi router. Right? So things that don't have a screen, typically they're small. Right? Java is often used on those, although C is more common. Now, it is used in some science and engineering applications. So if you click that link down there, that will take you to this thing here, the 25 greatest Java apps ever written. And so if you just scroll down and take a look at what's there, right? NASA is actually a fairly large user of Java. Right? So the Mars rover controller, written in Java, which is kind of surprising, but apparently it's true. Right? And you'll see if you keep on scrolling, there's a bunch of other NASA applications here. So it is used by the science and engineering communities. It's just not super common. There are some video games that are written in Java. None of them are big AAA video games, right? So anything that has to run very quickly, probably not written in Java, right? But there are a lot of indie games that are written in Java. Okay, so you do, being a Java course, you have to install Java on your computers, right? So you need a JDK and you need this thing called Eclipse, which is an IDE, Integrated Development Environment. Now, if you programmed in Java before, it's possible that you have some other IDE installed on your computer, right? Maybe NetBeans or BlueJ or something like that, right? I guess Visual Studio Code you could use as well. You can use those if you want to. I'm not going to support them because I don't know every IDE, right? So the standard IDE for this course is Eclipse, and that's the one I recommend that you install. All right, any questions about how this course is going to run before I actually jump into the actual lecture material? All right, super. Next set of slides. All right, so I need to transition you from C to Java, because I'm assuming you all know how to program in C. Right? Okay, so C program, right? So this is your standard C program for Hello World, right? You include standard io.h, right? You write a little main function, right? It either looks like int main void or int main, int argc, char star, argv, square bracket, right? You may still have nightmares about the star and pointers, et cetera, et cetera, et cetera. Yes? Right? The nice thing in Java is no pointers in Java, so you don't have to worry about them. You don't have to worry about free or malloc either. Java takes care of all that for you. Right? So that's your standard C program, right? It always starts from main, right? It always looks something like that, right? One of these two. Depending on who taught you C, you might have seen a different version of main. So you might have just seen int main square round bracket, or something like that. Those are all old forms of C. These are the two standard forms in modern C. Right. Okay, so Java looks almost exact. So I guess there's a few things I should say. So if you know how to write a loop, an if statement, if you know how to make variables, then in C, then you can do all of that in Java because it's exactly the same, right? So there's actually the core language. You already know it. You more or less already know it, assuming you remember your C course, right? So excuse me, Java looks a little bit different, right? So there are differences, of course. It's a different language. All right, so the equivalent program in Java consists of the following lines of code, right? So there's this public, then class, and then something, right? There's braces. just like in C, right? So Java is a brace-based language, right? So it denotes blocks using braces. There is a main method, but it doesn't look exactly the same as the C main function, right? So the main method in Java looks like public, static, void, main, round bracket, string, dot, 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 args. Right. Printing out something in Java is easier than printing something in C. It looks a lot more verbose, right? That's pretty easy, right? Puts a string or printf a string. It looks pretty easy, right? In Java, you have to write system.out.println, round bracket, and then the string you want to print, right? Just like in C, a string literal in Java is enclosed by double quotes, right? So exactly the same as in C. Right. Case here matters, right? So that big S matters, right? That little o matters, that little p matters, right? Println, that prints whatever this is, and then goes to the next line, right? So if we were to run, I guess I have to make up a version of this because I don't have it handy. Sorry. So I'm just going to make up a version of this in Eclipse. I'm going to show you how to do all of this in the lab, right? So don't worry about following along right now. I'm just going to quickly do this. Where are we? Oh, hang on. Sorry. I need to cook up another project. Just a second here. Okay, I need to make a class, like that. I'm going to call it hello world. We're going to put in a main method. So Eclipse does all this for you, right? So it generates the class for you. It generates the main method for you. All you have to do is add the code. So that's kind of nice. So, sorry. My keyboard is too small. So system. Hello world, like that. Right, semicolon at the end, just like in C. Right. Any second now, what's going on here? Must declare a named package. Oh yeah, sure. Okay, there we go. So once you've got that written, so in C you would compile your program, right? You'd look at the compiler output to make sure your program actually compiles. If it compiles, then you would run it, right? When you're inside an IDE like this, the IDE takes care of all that for you, right? So Java is a compiled language just like C, so you have to run it through a compiler, right? Assuming it compiles correctly, you can then run the program. There's a little green button up here that looks like a play button. You just press that and it runs. It'll do all the compilation and running for you. Okay, and then we have the, right, sorry. So assuming I actually did this right, that would actually run. I'm just going to do this again. This is all happening for very good reasons, but they're not relevant right now. Okay, so I'm just going to grab that. Where's lecture one? Sorry. Aye. Okay, and take that and drag that up there. All right, and now it'll run. Right, and then it spits out the output in the console down here. Right. Okay, so there's a second form of main, right? You can use string dot dot dot, or you can use string square bracket, right? If that looks like an array to you, that's because it is. It is an array. Right? So Java has this class called string, big S string, right? C doesn't have strings. I think I have the lecture. Hang on, I'm going to get to this in a second. C doesn't have a dedicated type for strings, right? So if you remember how does C represent a string, it's an array of char, right? Java actually has a special string type, which handles all of the string operations for you. Right? So it's much easier to operate with strings in Java than it is in C. Right? Okay, so I guess there's a few things I have to tell you about this. When you make your class, right? So every Java program resides in a class of some kind. Right? So this main method has to be inside something called a class here. Right? So when you make your class, you have to give your class a name. So the name of this class is hello world. Right? So Java has a convention for naming things. Right? C does not. Right? C programmers will name things however they want. Right? In Java, Java programmers are used to naming things a particular way, right? And the expectation in this course is that you also name them that way. So when you name a class, right, you always write it in what's called upper camel case, right? So the first letter is always a capital letter, right? The first letter of every word of the name is a capital letter when you name a class, right? So big H, hello, big W, world, right? So that's the way that Java programmers will expect you to name it. The Java compiler doesn't care. You can call it little h, little w. The compiler doesn't care, right? Java programmers care how you name things, right? So the convention in the programming language is to name classes in upper camel case. You can use an underscore if you want, but generally you should avoid those, right? So the class name has to start with a letter or an underscore. It can contain letters, underscores, and numbers, and that's it. So you can't put any funny symbols in your class name. You can't put spaces in your class name. Okay, so Java statements, they end with a semicolon, just like in C, right? It's not 100% true, but that's the easiest way to get that idea across, right? So you know that from C, a for statement does not end with a semicolon, right? It's for, brace, brace. There's no semicolon. It's the same in Java. Right? So C has no special type for strings, right? A string in C is just an array of char, right? So if you wanted to store a string in C, you would make an array of char, right? And then you can assign it a string literal, hello world, right? Remember in C, that thing has to be null terminated, right? So I don't know if you remember all that, right? Remember there's a \0 at the end of that string, right? And you have to put it in if you're making the string programmatically, right? If you don't put it in, all of the C string functions barf, right? That's not true in Java. You don't care about the null terminator in Java, right? Java has its own type for strings. It's big S string, right? So it's big S because string is a class, right? And so every time you make a string in Java, you end up with what's called a string object, right? An object whose type is string. So when you write out the string literal hello world, right, underneath the hood, what's actually happening is you're getting a string object made from that sequence of characters there, right? A reference to that string object is stored in the variable s. I'm going to explain references later, right? You can reassign s, right, which you can't do in C, right? So once you've got that array there, I can't on the next line write s equals something else, right? You can't assign to an array in C. Right? But in Java, you can reassign to a string object. Well, that's not 100% true. You can reassign to a string variable, right? So if I want s to be a different string, I can just write s equals and then some other string, right? I forget what language this is in, and I also forget what language that's in. I just looked it up on Google and picked some different languages. I don't remember what they are. Right? But you can just reassign. You can reassign strings. You can reassign a variable in Java. Okay, so you all remember how to use C strings, right? It sucks, right? It's very tedious. It's very error-prone, right? It's extremely error-prone in C, right? This is one of the reasons the Java language was created, right? So because you've got your own dedicated type for strings in Java, right? That type is able to deal with these tasks like joining strings, right? You all remember string cat, right? Join two strings. Right? Well, you don't have to do that in Java, right? So if I wanted to join these two strings in C, right, I would call strcat, right? Pass in s and t. If you remember what it does, it takes the string comma world and appends it to the end of the string hello, which is sitting in the variable s, right? If you also remember in C, if that array isn't big enough, when you call string cat and join these two strings, bad things happen. Right? In Java, you just write s plus t, and that concatenates two strings. It's even better than that in Java. If you take a string and you add anything to it, it will join the two things together for you, right, and produce a new string. Right? So the plus operator is Java's concatenation operator. Right? It takes a string and anything else and produces a new string. Right? So I can take the strings hello and then comma world, and then join them together with plus, and everybody's happy, right? So if you want to, we can try that out here, right? So string s equals hello, Oh. String t. So comma world. Right. I can join them together to get a new string. So I guess it's u, s plus t. And then I can print out u. So system.println, right? And I can print anything out in Java. So I can put in the variable u, and that will print out whatever the contents of u is, right? Which is also, wait for it, hello world, right? So that's nice. So there's a whole bunch of other string functions. We'll learn more about the string methods, sorry. We'll learn more about those later, right? If you want to print something in C that's not a string, you're stuck with printf, right? Or fprintf, right? Or if you want to print to a string, sprintf, right? Again, you're going to remember this sucks in C, right? You need to know what type you're printing. You have to pass in a conversion operator, blah, 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 right? So if I have a string, if I have a number, 212, and if I have a string CMPE, and I would like to print that CMPE 212, I can use printf, right? %s, so convert CMPE as a string, space, %d, convert 212 as a number, as an integer, sorry, \n, because I want a new line, right? Subject and number, right? And that will print out CMPE 212, right? In Java, you just take your CMPE, your 212, and you just print out. So you can do it several different ways, right? I can print out the CMPE, then I can print the space, and then I can print the number, right? Print does not go to the next line, right? It prints something out to the console and then stays where it is on that line, right? Println prints out something and then goes to the next line, right? So I can print out CMPE followed by a space followed by the number followed by a new line, right? Or I can just use concatenation and print out the concatenation of all three things, right? And I don't have to worry about whether that's a string or that's a string or if that's a number. Java takes care of all of that for you, right? If you're going to do this, though, be careful. Make sure the first thing's a string, because if it's not, funny things happen. Okay, so all C variables have a type, right? You all know this, right? Whenever you use a variable for the first time, you have to declare the variable. You declare the variable by stating what its type is, right? You can't change the type in C, and variables can only hold values of the declared type, right? So S is always an array of char, right? T is always an int, right? ARR is always an array of int. Java is exactly the same thing, right? They all have a type, right? When you use the variable for the first time, you declare the type with the variable name, right? Type can't change. Variable can only hold values of the declared type, right? So exactly the same as in C. Okay, so when you name variables in Java, they also have the naming of the variables also has a convention. Right, so Java programmers are going to expect you to use lower camel case for your variable names. Right? So lower camel case just means your variable always begins with a lowercase letter. If it's a multi-word name, the second, third, fourth, and so on word begins with an uppercase letter. Right? So here my variable name is s, lowercase s, right? Lowercase t, lowercase a, and then uppercase A, array, right? Because that's a multi-word name. Right? Again, the compiler doesn't care. Java programmers who are reading your program care, right? They're going to expect your variables to look like that. Comments in C are exactly the same as comments in, comments in Java and C are exactly the same, right? So the double / is the line ending comment in both languages, right? So // initial investment, that entire line's a comment. Right? Annual interest rate in percent, also a comment, right? You can put the comment after your code if you want, right? So that and the comment ends the line, right? So that's your, what is that? That's your compound interest formula there, right? Notice here, right? Just like in C, there's no exponentiation operator, right? So remember in C, if you want to compute x raised to y, you have to call pow, right? In Java, it's exactly the same, except you write math.pow. Right? Math is the class that contains the method called pow. Right? Everything in Java lives in a class, right? Including your mathematical functions like pow and exp and things like that. Right? So to use those functions, you're going to always write big M math dot and then the name of the function. Right? All the operators are exactly the same. Right? If you want a multi-line comment, again, it's exactly the same as in C. Right? /* ends with */. Right? And unlike the line ending comment, you can stick one of these comments in the middle of a line of code and everything's just fine. Right? Exactly the same as in both languages. True, false. So in C, there's no logical type. Right? So there's no type to represent true and false. Right? So that's C99. That's probably the way you guys were taught as well, I'm guessing. Right? So if you wanted something to indicate true or false, you would use int, probably. Right? You'd probably use 0 for false. Yeah, right? Probably use 0 for false. You're probably told to use 1 for true, but any non-zero value is interpreted as true in C. Right? So here TF is short for true false. Right? So it's just a variable that indicates whether something is true or false. Right? Java has a dedicated type for this. Right? So your dedicated logical type in Java is called Boolean, little b Boolean. You cannot use int in Java to represent true and false. Right? It doesn't work. Right? You must use the type Boolean. Right? There is no conversion between any other type in Boolean. Right? So if you want true, it's always if you want false, it's always little case false. If you want true, it's always little case true. Right? If you want a variable that holds a Boolean value, it's always little b Boolean. Right? You cannot convert from int or any other numeric type to Boolean. Right? Similarly, you can't convert from Boolean to any other numeric type in Java. Right? So there are no built-in conversions. Right? So here I can make a variable TF and set it to false. Right? I can write a little if statement. Right? So if that thing is true, it's going to print out true, and if it's false, it's going to print out false. Right? Change that to true, it'll end up printing out true. Right? Lowercase t, lowercase f. Right? You can't uppercase the t and the f. Right? Which is confusing if you also know Python. Right? So in Python, it's big T true, big F false. Right? In Java, it's little t true, little f false. Right? All right, so in C, there are your integer types. Right? I don't know how many of these types they actually showed you. Right? But in C, there are both signed and unsigned versions of every type. Right? So you can have a, I didn't put it here. Right? So you can have an int, which is a signed integer value. Right? Or you can have an unsigned int, which is an unsigned integer value. Right? So values between 0 and some positive value. Right? Signed value is negative, some negative value to some positive value. Right? And there's a whole bunch of these in C. Right? In Java, there's a lot fewer of them. And there are no unsigned types in Java. Right? So your integer numeric types in Java are byte, char, short, int, and long. The only ones we care about are char, int, and long. Right? Byte and short we won't use in this course. Right? Is it here? Okay. I'll talk about it later in another lecture. Right? So int is similar to a C int, right? And long is similar to a C long. They're not exactly the same thing, and I'll get into the details in a later lecture. Right? But for the purposes of this course, they're going to behave the exact same as what you learned in your previous courses. Right? Char is the same. Well, sorry, it's not the same either. Char in Java and C are both meant to represent characters, right? But they are actually integer numeric types, right? So even though that looks like the character A, that's actually an integer value of some kind underneath the hood. Right? Floating point types exactly the same as in C and Java, right? They even behave exactly the same. Right? So float and double are your two choices for your floating point types. C, you have long double. Java doesn't have long double. Right? If you learned scientific notation, Java also has scientific notation. Right? Exactly the same as in C. So the only difference here is no long double in Java. Otherwise, it's all the same. Right? Okay, so far this should be good news for all of you, right? Because if you remember your C, you're basically good to go for basic Java, right? Okay, so the big difference between the numeric types in C and the numeric types in Java is that in C, right, if you use an int in C, the way that that integer value is represented on your computer depends on the computer that you're running it on, right? So C says that an int is an integer value, and it has to be at least 8 bits long, if you know what a bit is, right? If you don't know what a bit is, it doesn't matter, right? But it has to have at least 8 binary digits, and that's all that it says, right? Which back when Java was created was a problem, because you would write your C code on one computer and you'd try to take it to another computer and it would behave completely differently. And that's because your representation of your variables are different on your two computers, right? On your one computer, your int might be 16 bits. You take it to another computer, it might be 32. You take it to some very strange old computer, it might be 10 bits long, right? The standard doesn't say what number of bits should be used to represent an int, right? Or any other type for that matter. Right? All the C standard says is that car has at least 8 bits, and everything is at least as big as a car. Right? That's more or less, there's a few other things that the standard says, but that's all that it says. Java, one of the designing principles was that when you write a Java program on one computer, it should run on any computer. So they mandated how big each one of these things are. Right? So in Java, an int is always 32 bits. Right? A long is always 64 bits, right? And so on and so on and so on. Don't memorize this, it's not important, right? I guess the one thing to take home from this point right now is that the amount of memory these occupy, these are all finite, right? So an int is exactly 32 bits long. Because you have a finite number of bits, right? That means you can only represent a finite range of numbers. Right? So there is a minimum integer value that you cannot go below. Right? So if you have an int variable, you can't store a value that's less than minus 2 to the 31. It doesn't work. Right? Similarly, there's a maximum value. If you have an int variable, you cannot store a value that's bigger than 2 to the 31 minus 1. Right? This has all sorts of implications that we're going to get into later on. Right? In C, you don't know what that 31 is. Unless you actually unless you actually look up what it is on your particular computer. Okay, more good news. No pointers in Java, right? So Java has no mechanism for accessing memory directly, which is what a pointer is, right? A pointer is just a memory address, right? Java doesn't let the programmer get to an actual memory address, right? So there's no way to directly access memory in Java. So there's no pointer types, which means you don't have to worry about pointers, right? You don't even care about allocating memory for objects. The language does that for you, right? So there's no malloc needed here, right? The only exception here is for arrays, right? So when you make an array in Java, you have to tell Java how big the array is, right? How many elements are in the array, right? You don't deallocate stuff in Java. Right? So if you malloc something in C, you've got to free it later on. Right? If you don't, you've got a memory leak somewhere in your program. Right? Java takes care of the deallocation for you. Right? Again, this is no, just a test. This lecture is almost over anyway. So just bear with me for another minute. All right. So there's no memory allocation or deallocation. The language takes care of all of that for you. Now, there is a price that you pay for this, right? This is great for the programmer, right? The programmer doesn't have to deal with this problem anymore, right? But all that's really happened is that the problem has been pushed off somewhere else, right? So something has to deal with the allocation and deallocation, right? And that something is the thing that your Java program runs on, right? So your Java program runs on what's called a Java virtual machine. So when you run a Java program, it doesn't actually directly run on your CPU. It runs on a simulated computer, which is running on your CPU, right? And so Java is slower than a language like C, right, which actually runs on your CPU, right? So there is a price to pay for all of this, right? But it does make your life a lot easier than in programming in C. Right? Okay, so I'll call it quits there. We'll pick it up from this lecture slide in the next class.